In this tutorial, we are going to talk about dimension analysis. So basically, when we're talking about dimension analysis, we're talking about the units. Okay? Sometimes, if you have been given maybe, let's say 10 kilometers per hour, then you are trying to convert this one into meters per second. Now, there is what we call dimensions. So that dimension analysis is the one which is going to be helping us to come up with what is the proper units. Okay, but before we do that, we know that we have got what we call the basic units and the derived units, or you can say quantities. Now, the basic quantity, we only have three basic quantities, which is what we can say units, which we have what the mass, so we can say they are quantities. Then we also have the length as well as the time. Now, these three guys, we can't derive them. They're just there. So those are the things which we are calling as what? The basic quantities. What of the derived quantities? Now, the derived quantity or derived units, you can talk of when you combine the basic ones, you can combine one or two, maybe two, three, and then they're going to give you a derived one. Let's talk of force. Okay? We talk of force. Okay, now we know that mass it is in kgs. Then we also know that length it is in meters. We also know that time it is in second. Now when we talk of force, force is Newton. But we also know that force is what is mass times acceleration. We do know that acceleration is also velocity, change in velocity divided by time. Okay? But now we know that this change in velocity it is meters per second. So as you can see, it is the combination of the mass of the length as well as what the time. So derived quantities, these are quantities which are got which we can get them from what the basic ones. So now under dimension analysis, we are going to be focusing on what the basic units or the basic quantities. Now, what are these basic quantities we are talking about? The basic quantities which we are talking about, there are only three. We are going to be dealing with the mass, length, and time. Now, first, before we even go there, using dimension analysis, how can we convert, let's say that we have 20 kilometers per hour. Then we are trying to use dimension analysis to come up with what? To find the answer in what? In meters per second. So what we're going to do is we're going to write 20 here, then we're going to say kilometers, then we're going to put hour here, times. Now we're going to say in 1 kilometer, how many meters do we have? We've got 1000 meters. Then times again. In 1 hour, how many minutes do we have? We have got 60 minutes. But our goal is to find the answer in seconds, so we're going to say that again in 1 minute, how many seconds do we have? We have got 60 seconds. So what we are going to do from there now, using dimension analysis, we can cancel this. Then we can also cancel the hour. We can also cancel the minutes. So now from here we are going to say that it's going to be 20 times 1000, then 60 times 60, which is going to give us, so we can say that 20 times 1000 is going to give us a 20,000. Then we divide this one by 60 times 60, we are going to get 3600. So we can cancel the zeros, so we are remaining with 200 divided by 36. So now, what is 200 divided by what? 36. Okay, by using the calculator, we can see that it's going to be 200 divided by 36. We are going to get 5.555 meters per second. So you can just say it's 5.56 meters per second. So this is how we can use dimension analysis to, so dimension analysis, it helps us to convert the units from, if you have got, you want to come from kilometers per hour to meters per second, or you want to come from meters per second to kilometers per hour. So basically you can change any units using what? dimension analysis. So now let's say that we have got um let's say we have maybe 20 uh, micrometer per second. Now we are trying to convert this one, or before we even do that, what can we do if we want to convert we have 20 micrometer, then we want to go it into meters. Now we know that coming from micro, we know that micro is just basically 10 to the power to the power 6. So what is happening there is that you are going to use them. If to use dimension analysis, we are going to say that 20 micrometers times 10 to the power 6 micrometer, there is what, 1 meter. So then these two guys, they will cancel, meaning our answer is going to be 20 times 10 to the power negative 6 micrometer. Same applies with nanometers, same applies with the same thing. But now our main interest here is we want to talk about the mass, the length, as well as what, the time. Now these are the things which we are going to be using under dimension analysis. Now what is happening there is that mass we know that it is in kgs, then length it is in meters, then time it is in second. But what we are going to be doing is this: we are going to be, after putting this, now the final answer when you want to report it in dimension analysis, dimensions is going to be this one. Instead of it writing the instead of us writing kgs, it's going to be, we are going to be representing it with what, the capital M. Now this capital M, we are going to be putting it in what, in brackets. Same applies to length. So this length, what is going to happen there is that what is going to happen there is that this length, we are going to denote it with what, the L. Now this capital L, now we put it in brackets. Then now the time is going to be what, is going to be in as well as T, so but it's going to be in capital T. So these are the things which we are going to be using. Okay, but now there are some rules which we are supposed to be following when doing what, dimension analysis. And what are those rules? Okay, so rule number 1, when you are dealing with dimension analysis, we need to consider to say we are going to have what we call the constant. Or let's take, for instance, we have got an equation which is force is equal to k, then mass times acceleration. So this k is going to be considered as what, a constant. Okay, now we're not going to be tampering with what, the constant. But the first rules of dimension analysis only applies to mass, length, and time. Now these guys, we're going to be using the capital M, then we put them in brackets, the length and the T, the way we have these three guys. Okay, that is the first application which we need to understand under dimension analysis. Then now we need to understand again that dimension analysis does not give the value of k. So we can't get the value of k using dimension analysis. If you have got a constant, we are going just to be ignoring the constant. We can't get the value of k using dimension analysis. Okay, now another part is we need also to understand that dimension analysis, it doesn't apply to logarithm, exponential function, and trigonometric function. It doesn't apply there. Okay, then the last one, which is very important, is dimension analysis can only be, you can only get the dimensions of the particular equation to only one part. For example, let's take, for instance, we have the distance is equal to ut plus half at squared. So now what we are trying to say here is, if we want to prove that this part is equal to this part, you can't get the entire part here, right hand side. Why? Because there are some things which we can't add there. So if you want to prove, if you are supposed to get only one part, if you want to prove, you can just get this part, or you can just get this part. Okay, then you can compare this part and this part only, also this part and that part. So you are supposed to get the same answer. You compare this one and this one, then you get the same answer, also the same one with this other one. If you are getting different thing, meaning it is dimensional what wrong. Okay, so now another issue which we need to understand is sometimes sometimes uh, if maybe you have been given an expression, sometimes they're going to be telling you this. Let's say um, we know to say it's going to be difficult for us to know to say, for example, let's take for instance to say we have got an equation which is v initial times t plus half at squared. But using dimension analysis, we really don't know if there where there is t we had the power. But now there is a way which is going to help us to find those the what the powers of everything which we are going to have. So now let's take for instance, they ask us a question to say we want to find maybe dimension analysis. Then let's say maybe we have what um maybe we just say we have got an expression, then we have been given to say we are supposed to derive the expression for acceleration if it is related to what, to velocity and the radius. Let's say that we have got the velocity, which is going to be v, then we also have the radius. Now they want us to find the formula for acceleration. What is the expression for acceleration? Now basically we don't know if it was v over r or if it was v times r, but the first step, you are supposed to like the proportion. So we are going to say that this acceleration has to be proportional to what, vr. Now that is the first step. When you've been given any information, just like that step. If they want you to like the formula, just like that step to say you are going to be given maybe v, so you like acceleration is going to be given by, it's going to be proportional to v times r. Then now the next thing is we are supposed to replace where there is this proportion to equal to k. So we are going to be replacing this part with where there's what, this alpha, meaning that k is constant. We really don't know if we had a number, so it's going to be representing as maybe we had a 1, we don't know, meaning that where there is this part, I'm going to replace with what, equal to k. So I'm going to say that acceleration is going to be equal to k vr. Then now from there, what we are going to do is we are going to, this is the constant, we don't have to worry with the constant, okay, but we are supposed to worry with the v and r. We don't know if those two guys had got some powers. So what we can do is we are going to put, you can just choose any number, okay, you can choose any letters of your choice. You can say that v, I can represent it with what, maybe a, then r, b. So my goal, this is the original formula which we are going to have, but my goal is to find the value of a and b. Okay, we know that acceleration is given by what, is given by mass times divided by what, this squared, which is the same as m divided by this squared. So we have agreed here that where there is mass, we are going to be putting this capital, this is meters, sorry, this is meters per second, meaning that where there is meters, I'm going to be putting is length, so I'm going to say it's going to be length. So where there is, I'm going to put this where there is mass of meters. Then where there is second, I'm going to be putting what, once more, where there is this time, we are going to be putting where there is what, seconds. So meaning that acceleration is going to be mass divided by squared, it has to be equal to k v a, then we have r to the power b. So what we are going to do at this point, we are going to say that this is the same as, if I can write it, m times s to the power negative 2, okay, has to be equal to k v a r b. Now if I have that, then it's the same as, I can say that where there is m, let's put length, so I'm going to say it's going to be l it's going to be L. Okay, I'm going to put L. Then where there is S, I'm going to put T, but that T is going to be what? It's going to be T square, T to the power negative 2 has to be equal to, then we have got K. We also know that velocity is given by mass times this, meaning that I can also say that before we even do that, we can say that velocity is also what? M. So this M is a set, we can also write M S to the power negative 1. So I can say 2 times negative 1. But we know that radius is also in meters, so I can say times meters. Then I'm going to put where there is meters with it. So I'm going to have this, then T to the power negative 2, then K. Then where there is meters, I'm going to put length. Where there is seconds, I'm going to put T now to the power negative what? To the power negative 1. But we need to understand that everything here, it is raised to the power what? To the power A. We want to find the value of A. Then times the meters again is in what? Is in, we're going to say is length. Okay, so this one we have said is going to be B. So our goal is to find the value of A and B. What are we going to do? Let's create space here. Now, what we have there is we have left hand side, we have got length, then we have got T, and then raised to a power negative 2 has to be equal to, we have K, then so K is constant. If you want, you can just leave it. Then you have got length. Then let me just also put this length here, this one. So I'm going to put this A now inside, so it's going to be A to the power A. Then you have got also this length, which is going to be to the power B. Then I also have times what? T. Now there is negative 1, so it's going to be T, then negative A. Okay, now what we are going to do now from here, we are going to compare. If the bases, we have got this, if you know the indices, if you have got x times x, then this is to a power 2, this is to a power 1, so you just add the powers. Okay, meaning that it's going to be x to a power 3. So now here we have got same bases, we have the length as well as the length. So what we can do there, we can just add these two guys. Okay, then we are going to have length, then we have time to the power negative 2 is going to be equal to, I've got K, then L, I'm going to write just one L, then it's going to be, now adding those two guys, it's going to be A plus B times T is going to be raised to the power negative A. Then now we are going to compare the left hand side and the right hand side. We know that the bases are the same. This is raised to the power 1. So the bases are the same. We can cancel the base. Then we can set them equal to each other. So we are going to say that A plus B is going to be equal to 1. Okay, so we are going to have A plus B is going to be equal to 1. Then at the same time, this one, the one for T, we have got negative A is equal to what? Negative 2. We have compared this T and that T, the powers only. The bases, we cancel them because they are the same. So meaning that A is equal to 2. Okay, cool. So if A is 2, what is the value of B? So if this is 2 plus B is equal to 1, meaning B is going to be equal to 1 minus 2, which is B is going to be equal to negative 1. So we have found the values of A and B. So we are supposed just to come back to this original equation and then we plug in the values. So this is what we are going to have. We have our formula, which is A is equal to K V to the power A R to the power B. Okay, so our expression is going to be equal to V A K V, then A, the value of A is 2 times R raised to a power negative, the value of B is negative 1. Now when we have negative 1, it's the same as we can just put it A is equal to K, then we can say V squared times 1 over R, meaning I've removed the what? The negative, which is the same as A is going to be equal to K, then V squared divided by what? R, meaning that this is the expression which we wanted to get. Okay, so just follow those simple principles, then we are home and dry. Okay, now let's say that we have also, maybe we have got um, let's have this. Let's try to solve this. Let's consider to say we have the formula for kinetic energy, as in kinetic energy is given by the momentum squared divided by what? 2m. Okay, and let's say that kinetic energy has been given that uh, the dimensions for kinetic energy is kgs, and then we have meters squared, then we also have seconds to the power negative 2. Okay, now how can we use this information to find the or to determine the units for momentum using the dimension analysis? So how can you do that? So to find the units, what are we going to do? Okay, so now what we are going to do is we are going to make this guy as subject of formula, the momentum. Okay, so we're going to cross multiply, so we're going to have here over 1, so we're going to have p squared is going to be equal to 2 times m times kinetic energy. But basically this is a constant, we can just leave it, it will not affect anything, because we are trying just to come up with the units. So this constant will not affect anything. So we can say that p squared is going to be equal to kinetic energy times m. So to get the p, we are going to say that it's going to be the square root of kinetic energy times m. Okay, let's now put the what? The units. We know that this is the mass, okay, which is also kgs. So what we are going to do now from there is we are going to say that momentum is going to be equal to, we know that kinetic energy, we have been given that it's kgs, and then we have what? Meter squared times second to the power negative 2. Then again, this is what? The mass, which is also in kgs, but everything is in square root. Now square root, if I have got x plus 1, they are in square root, this is the same as x plus 1 to the power negative half. Okay, so now what we are going to do there is this. We are going to come out, we are going to say that p is going to be equal to, we are going to say it's going to be kg. So now I can just do kg times kg, I'm going to get kg squared times m to the power 2 times s to the power negative 2, everything raised to the power half. I've come up with what? The square root. Meaning that from there now I can say that momentum is going to be equal to, I can now distribute the half. So I'm going to have kgs to the power 2 times half, then times meters to the power 2 times half, times s to the power negative 2 times what? Times half. So at this point we can cancel this, the half, even here they will cancel, here we're going to remain with negative 1. So we're going to have momentum is equal to kgs times meter times what? S to the power negative 1. And this is true because momentum is given by mass times velocity. So mass is kgs, velocity is mass per meters per second. So as we can see, these are the units for what? For momentum. Okay, so now using the same concept again, how can we come up with what? Let's say that we have been given the same thing. Let's do this. Let's say that we have been given the units for force as maybe kg meter per second to the power negative 2, and then we want to come up with simple equation of force. Okay, let's say that we have been given the what? The time as well as what? The momentum. Okay, so we want to find the what? Let's say that given that the units of the force as kg meter per second, or kg meter second to the power 2, write a simple equation relating the constant force exerted on an object, an interval time is given during which the force is applied, and the resulting what? Momentum of an object. And we have said that momentum, we have come up with the formula to say, or the SI unit to say is kg minutes, then this to the power negative 1. So now we have also been given that. Now we are trying to come up with what? The formula which is going to help us. Now remember, the principle is going to be, we want to find the formula for what? For force. Okay? So now we are going to say that force is going to be proportion to momentum times time. Okay? Then now we are saying that where there is this alpha, we are going to replace with equal to k, this part. So we're going to say that force is going to be equal to k pt. K is constant. So I'm going to raise these guys to any letter so that I find the value. So this is the formula basically, but we want to see what we're going to have. So I'm going to have, this is going to be x, this is going to be y, meaning I've got f is going to be equal to k p x t y. My goal is to find the value of x and y. So what I'm going to do is this. I've been told that this f, the force is kg meter s to the power negative 2 has to be equal to, then we are going to say that k, we have got k. So if at this, if I want, I can leave k, it's okay. And then I'm going to say, because I want just to find the what, the values of x and y, so I can leave k. And then I'm going to say that p is momentum, which is kg m s to the power negative 1, but everything raised to the power what? Raised to the power x. Then time, it is in seconds. It's going to be seconds raised to the power what? Y. So now what we need to understand again here is this. We know that where there is kg, it is basically mass. We are going to be representing with m, then you put them in brackets. Where there is meters, we are going to be putting l. Where there is s, we are going to be putting what? T. That is the only principle which you are supposed to follow. So I'm going to continue there to say, where there is kg, I'm going to put m, capital M. Then this one I'm going to put what? The mass. The meters, I'm going to put what? The length. Then this one I'm going to put t to the power. I put first this, then to the power negative 2 has to be equal to, same applies to this. So this one is going to be, I can just put big open brackets, and then I say I'm going to have mass, just like that, times meters, which is length, just like that, then times t, just like that, times raised to the power that one, everything raised to the power x, and then we have what? This one is going to be t raised to the power this. Okay. Now from there we can also see that we can now distribute x. We can now distribute x. So we are going to have m, and then we are going to have l, we are going to have t, and then we are going to have what? We are going to have, this has to be equal to this m. Now I'm going to distribute it. I'm going to have, I've multiplied it by x, then I'm going to have l. So l is going to be also x, and then I also have what? I also have t. Okay. I also have t. So I have t, which is going to be equal to raised to the power negative x, and then I also have what? Another t, which is raised to the power y. So you can just get rid of this. Now from there we can also see that this mass, these ones, they are raised to the power 1. Okay, so we have got, let's now do this. We have got, let me rewrite this. So we have this, so it's raised to the power 1, raised to the power 1, then t raised to the power negative 2 has to be equal to. Now we can also see something here in common. We have got t and t. So these, if they are the same, meaning the powers, they are going to do what? They are going to be cancelled. Okay, meaning that what we are going to have there is going to be the mass x, then we have the length, it's going to be x, then t, I'm going just to write 1t. After writing 1t, meaning these two guys we can add them, so it's going to be negative x plus y. Now we can compare them. So we have got left hand side, which is mm. So we have got x is going to be equal to 1. X is going to be equal to 1. If I compare L and L, again is x. As you can see, again x is going to be equal to 1. So we are getting the same values. Let's go to the last one. So we have got negative x plus y. This part here has to be equal to this part of t, which is negative 2. So we have found that x is already 1, so I can put negative. It's going to be negative 1 plus y is going to be equal to negative 2, meaning that y is going to be equal to what? Negative 2 plus 1, meaning that y is going to be equal to negative what? It's going to be equal to negative 1. Okay, meaning that, so now we have the value of x and y. Our equation is this is our original equation. So one just to plug in the values of x and y, then that is the expression which they want. So I'm going to get rid of this, and then we are going to say that the force is going to be equal to k px ty. So where there is x, let's plug in the values now. Where there is x, let's put p is going to be x. We have found that is what? It was 1. Yeah, x was 1, then t is what? It's negative 1. So we can also say that f is going to be equal to k, then p, this one is same as 1 over t. Then the final formula is going to be k p divided by t. So this is the formula which we want to get. Okay. Now, what if maybe we want to find, maybe we have been given using the dimension analysis, then let's say we have been given to say we have got the radius of the circle. Let's say that this is the circle, and then the radius we have there. Then we have been told that the radius is 10.5 plus or minus, and then we say 0.2. So this 0.2 is just an error, certainty error. So we are going to say this. Now the question is, if maybe we have been asked to say what is it, find the or calculate the area of the circle. So we know that area is given by what? It's given by r what? By r. So now this pi r, if it is the full circle, what are we saying? Okay, so if it is the full circle, meaning that what is happening there is this: we want to find the area of the what? We want to find the area of the circle. So now the area of the circle is given by the formula 2 pi is given by the formula pi r squared. Okay, so now if that is the formula, we are now trying to find the area of what? The circle, but we have got what? The area which is 0.2. Okay, so now how can we come up with the formula which is going to help us to find the what? To find the area. So since we have got two things here, we need to understand this. We have got this radius as well as the area of the radius. So we are supposed to say that area is going to be equal to pi r I'll just say capital R, then I'm going to put plus or minus, then I'm going to say pi again squared, then small r, then I'm going to put them in brackets. So there I'm going to say that area is going to be equal to pi squared, then I put the radius which is in meters already, so it's going to be 10.5. Now 10.5, sorry, it's not pi squared r, it's pi r squared. I thought maybe I've written pi r squared. So it's supposed to be area is going to be equal to pi r squared. So I can say capital R, then it's going to plus or minus, then again pi r squared. So I'm going to say that area is going to be equal to pi, then my radius is 10.5, I square it, plus or minus, then pi, I also do this one 0. So this one is for this one 0.2, and then I square it. So my area is going to be equal to, so if I get 10.5, I square it, times pi. Okay, I'm getting 346. I'm getting 346.4, and then I can say that this is going to be plus or minus. Then I'm going to have what? 0.2 squared times pi. Then this one is going to give us what? 0.13. I've just rounded off. Then you can put them in brackets and say it is meters. So for you to find the circumference, you are going to use the same principle. Then you come up with everything. Okay.